The broadcast is now starting. All attendees are in listen-only mode.
All right, good morning, everyone. Welcome to the webinar and thanks for joining. Christiana and myself, Joanne, are this year's Technical Symposium coordinators for the Hull and Humber IChemE Member Group. But as you know, with the current pandemic restrictions, we're going to postpone that till next year so we can all meet in person. For context, under these unprecedented times, we'd probably be gathered in the room today for the biannual Technical Symposium, which is normally based every 2 years on a topic most relevant to the Humber industrial cluster. This year, we decided to make the best of the current challenges and open it up to a much wider audience via a webinar. I wanted to take this time to acknowledge and give thanks to all the other speakers who had confirmed their availability for the face-to-face meeting, and we look forward to welcoming you next year again, hopefully. Some housekeeping before I hand over to Susanna. There should be a Q&A box in the right-hand side of your screens. You can pop it out using the icon on the top right-hand corner for that box for a much larger view. And Christiana will be helping Susanna moderate the Q&A at the end of the session. Okay, thanks Susanna for being flexible and agreeing to present today on managing creeping changes. This was one of the topics that we stated in the technical symposium. Suzanne is currently the deputy to the director for IChemE Safety Centre, but I'll hand over to you, Susanna, to tell us more about yourself and launch us into the talk. Thank you. Over to you, Susanna.
Thank you, Christiana, and thank you, everybody. Good morning, good afternoon, wherever you are calling from, or good evening even. Thank you for joining us in this webinar, and I hope that I will be able to convey some really interesting learning points and messages around creeping changes, because this is a topic that I discovered that is really like mysterious sometimes, but it is really not. So I try to give you some hints and tips and some useful recommendations, hopefully, how to treat these creeping changes in this webinar. And yes, let's start because time is running, and as Christiana kindly introduced me, I am the deputy to the director of the IChemE Safety Center. I've been working within the IChemE Safety Center for 3 years. Before that, I worked as a scientific research officer for the European Commission Joint Research Center, as well as I worked at the Hungarian Disaster Management as a Seveso, or in the UK COMA, site inspector. And my specialty is learning from major incidents and presenting them in a very, very structured way so that everybody can take what is important and what is relevant for them and take the message home. So over this webinar, I will highlight some of the aspects about creeping changes, and I would like to encourage you, which is I always do on my webinars, that please feel free to add your comments in the question box anytime. And in the end, we will come back to the questions, obviously. I may not be able to answer to all the questions, especially if they are really, really specific to the topic, but I will try to come back to you after the webinar even. So what I would like is that you have an interactive way of this presentation, because that is the importance, that we share our experience. And if I may miss a point or something, then just feel free and type it in the question box and say, oh, Susanna, by the way, I think this would be important. And then I will acknowledge it. And so thank you for your collaboration in advance. And now let's jump into this topic. So I would like to give you an overview around what is basically a definition of creeping changes. And then what is interesting, that I would like to link those aspects with the IChemE Safety Center lead process safety metrics. I will talk about that later in details. And then I present 2 case studies. Now, what is interesting about these case studies is that the first one occurred in a process industry. That is normal, that is usual, and that is something that you would expect. But the other one is completely another story, and it has nothing to do to process safety. But you will, I'm pretty sure you will take the message home, and you will start thinking about more broadly, more widely. And this is what we encourage at the IChemE Safety Center, that we try to think out of the box. Because our belief is that we can learn from other industries as well as we learn from other industries. If you remember that everything started with different kind of industries, and then we started exchanging information with each other. So for instance, chemical industries learned a lot from nuclear and vice versa. So somebody is having problem with the speakers, they can't hear us. So that let's see what are the case studies that I am going to present to you, and what happened, and what were the circumstances, and what are the leading metrics, so that you can apply those practical issues in your operation, so that you associate leading metrics that you can tackle the issue. So let's see, and of course, what happened, circumstances, and learning points. And in the end, it's really interesting that I also will jump into the details about what can you do as a manager, and what can you do as a supervisor or process engineer, and what can you do as an operator. And those learning points are really, really like dedicated and focused on these roles separately. And that makes the difference, because when you have any investigation report and all the recommendations, like hundreds of them, then obviously you go through them, but what happens, be honest to yourself, you forget most of them, except for those of you who have exceptionally really good skills and remember everything. But coming from my experience, sometimes I just forget some of the recommendations. Now, in this case, you can see that, okay, I'm an operator. What is that important issue that I have to pay attention in this case? So that's the difference, the structured way. Now, first example, these are not yet the case studies. These are just to set the scene and make you more like understanding what is creeping change about. So I don't know if you are familiar with the Royal Air Force Nimrod accident that occurred in 2006, but this is a prime example of creeping changes, and that is an interesting case to see. So what happened, this particular RAF Nimrod suffered a catastrophic mid-air fire, and it was on a routine mission in Afghanistan in 2006, which unfortunately led to the total loss of the aircraft and the death of all 14 service personnel on board. Now, the direct cause was really not enemy fire, but leaking fuel being ignited by an exposed hot crossfeed pipe. The deeper causes were obviously, as you can expect, organizational and managerial. And what happened was interesting. Between 1983 and 2006, pay attention to the timeline, we are talking about 23 years. A fourfold increase in the number of fuel leaks on Nimrod happened. So, and that escalation happened gradually over these 23 years. These leaks individually by the management were not considered as safety critical. So learnings were not applied in terms of the whole system. One by one, the cases were solved, so to speak, and then also changes to the original design in the aircraft happened over the years, and most potentially without any risk assessment that actually focused on the whole system. So if I change something within the system at one point of time, how it will affect and what will be the overall impact on the overall system like 10 years later. I know we are talking about such timelines, but be aware this is the main feature of creeping changes. And so this was what happened in this case, that accumulation of these fuel leaks over 23 years had been unnoticed. or ignored and resulted in the ignition of a fire and subsequent explosion. So what next? If you happen to travel to London, then you come across with King's Cross station. That was a fire that occurred in 1987. A fire broke out at King's Cross St Pancras tube station, which is a major interchange on the London Underground. What happened was the fire started under a wooden escalator serving the Piccadilly line, and within 15 minutes it erupted in a flashover into the underground ticket hall, and it killed 31 people, injured 100. Now, the accident started with smoldering, and the fire had started due to a lit match being dropped onto the escalator. Why is it important in terms of creeping changes? Because over the years, similar fires had happened before, but no escalation. So it didn't end up in any flashover or explosion or anything like that. So the hazards were underestimated, and staff knew about these occurrences, but they were, at a certain stage, they were complacent because there had never been a fatal fire on the underground and had been given little or no training to deal with fires or evacuation. So this happened over years, and all of a sudden a big fire broke out. I'm pretty sure that you are familiar with the case of Costa Concordia, which was a cruise ship that struck rocks and eventually sank when it sailed at high speed too close to an island in a maneuver called a salute. The reason for the salute is normally to thrill passengers and people on shore at how close the ship can come. There does appear to have been a history of Costa ships performing salutes over many, many years. Now, this deviant activity may have been normalized in the company culture, and this is the aspect about creeping changes around normalization of deviance. So what else? Shell Mordyke, there was an explosion after a runaway reaction occurred. Here, the change was that there were changes in the design originally. The original design was altered, and then they used a new catalyst in the system, which catalyst was tested in normal operation. However, it was not tested during startup, and it was thought that it was inert in all kind of situation and circumstances, but it wasn't. So all these changes and small modifications in the design, originally design, that occurred over time. And obviously, we are all aware of Texas City refinery explosion, where you may all be aware of what happened, that over years, those changes to the original design accumulated, basically. So that if you think about creeping changes, these are a couple of examples, because I could potentially flood you with all these accidents here, but we obviously don't have time for that. But just give you the hint around what I want to talk about. And if I just struggle with words, it's because I'm so excited about this topic. Apologies for that. And I can give you even a definition if you want to see a definition, because people really, really like definitions. So what are creeping changes? How can I identify what I'm talking about? These are accumulation, and this is coming from the HSE originally. So accumulation of minor, teeny tiny changes, which are often ignored or even accepted as the new norm, but which over time can add up to a big change and ultimately lead to a major incident. Now, before you start taking notes, I would like to tell you that you will receive the slides. So just relax and I would say enjoy the flight, but enjoy the presentation. I try to just go through the slides. Apologies for the disturbing image, but this is something that I like to use, this fable. It's the boiling frog. It's the boiling frog, which is a fable that describes a frog being slowly boiled alive. Sorry if I'm being insensitive, but I want to make a point here, and this is just a fable. The premise is that if a frog, don't try it at home, okay? If a frog is put suddenly into boiling water, it will jump out. But if the frog is put in tepid water, which is then brought to a boil slowly, it will not perceive the danger, interestingly, and will be cooked to death. Sorry to say. Now, the story, why is it important in this case, is that it's often used as a metaphor for the inability or even unwillingness of people to react or to be aware of sinister threats that arise gradually. This is a key word, gradually, rather than suddenly. So after this shocking image, I would like to talk about the theory behind. So the theory behind creeping changes is that it's important. If you remember the Swiss cheese model, it's quite static. And nowadays, companies start to recognize that they can prepare dynamic Swiss cheese models, because what they discovered over the years is that here's the surprise: no industrial sites are static, and everywhere you can see changes. And what are the changes that we are talking about to the original design? It can be because of aging of the facility. Now we have more and more aging assets, obviously, because those industrial sites were built earlier in the 20th century, so that they are obviously aging and coming to the end of their life cycle. It could be because of degradation of equipment over time, together with organizational changes. Mind you that we are not only talking about equipment or pieces or technical materials here, but we are talking about organizational changes as well. And obviously, I already mentioned normalization of deviance, which completely fits into this category of creeping changes. Now, I'd like to show you what are the main aspects, and so what are the features that you can associate with creeping changes. And if you feel like, then you would, and if you would like to, then please, I encourage you to add your particular features, aspects, or thoughts around creeping changes, if you wanted to the question box. So this can be physical degradation, physical changes to the equipment, to the installment, to the plant. It could be organizational change, change in ownership. That was one publication that was recently being released by the OECD Working Group on Chemical Accidents. That is a really, really good read. Or that when you alter from the original design for some reason, and this is happening basically every day, not every day, but very, very frequently. Or you have new processes in place or modified processes, or you have you are losing skills and knowledge, or hire new people to your operation. So that could also happen. And there is also an aspect of creeping changes when you change the culture within the company. And this is what you can see in when you have change in the ownership. So for instance, then you can see these changes. And why is it difficult to identify these changes, and why is it such a topic that we are really struggling to understand? It's because these changes are really small. More than often it's not preliminarily thought through or wanted or desired, unplanned, and these are really gradual and not noticed changes. And they can lead to normalization of deviance when you create a new norm based on the new practice, based on what you changed in the system, in the procedure. I mentioned to you earlier that I will be talking about how these creeping changes could potentially be identified using lead process safety metrics or indicators, as you wish to call them. And for that, I'd like to highlight our free guidelines. These are the documents that are published by the IChemE Safety Center and can be downloaded from our website. And this is about lead process safety metrics. And the other one, the other guidance document, is a supplementary guidance document around pressure relief device design and operational performance requirements. And what you can find in these guidance documents is that we work around 6 elements. This is the 6 pillars or the framework by the IChemE Safety Center: knowledge and competence, engineering and design, systems and procedures, assurance, human factors, and culture. And we are working around these elements that are underpinned by leadership. Leadership is crucial to all of these elements, and there are 21 lead process safety metrics identified. Now, I will take the examples of the case studies, and I will show you these metrics, how they can be associated with those circumstances and aspects about those cases, if you want to be prepared and prevent for future occurrence. And now this is the time when I will be talking about the case studies. The first case study, as I mentioned to you earlier, is about a process industrial case that occurred in the FCC unit. So what happened? What happened in this case? The fluidized catalytic cracker unit, or FCCU, was shut down following a power distribution failure and was being restarted after an 11-day shutdown. Now, during this startup, a significant leak of hydrocarbons was discovered, and vapor cloud formed and ignited, resulting in a serious fire. So workers escaped from the blast, and nobody got injured in this particular incident, which is really a good news in this case. Now, I would like to guide you through the circumstances. What led to this particular accident? And what you will see also that I underlined some terms, and I will explain to you why. So, the leak was and occurred as a result of the failure of a T-piece connection at the bottom, at the base of the debutanizer column, which found a source of ignition nearby. The T-piece connection was originally installed in the 1950s, and it was correctly specified. However, it was incorrectly fitted, and plus it was hidden by legging. And the other circumstance was that there was no subsequent amendment to the plant layout drawings to identify that particular change or any change over the years. So what I underlined here was the creeping changes aspects, so that the T-piece was originally installed but incorrectly fitted, and then there were changes to the plant drawings, but they were not updated and they didn't reflect on the change. So what else do we have as we are talking about circumstances? So there were series of modifications since 1986. I think I didn't mention, but this particular accident occurred in 2010, 10 or 11. But you see the time frame here, that the first or a significant modification occurred in 1986. The pipework at the base of the column and a valve was removed. And prior to that modification in 1986, other changes had been made to the system. And one of them was that pipework at the base, and the valve was removed, which ended up in inadequate support for the remaining pipework and the T-piece connection. So that is resulted in this change, and this resulted in this that happened. And therefore, between 1996 and 98, the unit had experienced considerable difficulties when they started to start up and shut down. And obviously, because the unit didn't operate consistently, they had to increase the number of startups and shutdowns. And also, there were additional vibrations and cyclic stresses, obviously, because during startups, the whole process is under really, really high pressure and temperature. So all the circumstances at startup are really extreme, which ended up or contributed to cyclic stresses and vibration. So you can see here also some of the aspects of creeping changes, or what were the changes that were really, really subtle. A valve here removed, a series of modifications that may not have been identified in the management of change procedure, or there was no management of change procedure, and there was no risk assessment associated with it. And the underlying cause is also the increase in the number of startups and shutdowns. But what else? So 11 weeks before the incident, apologies, this one occurred in 2000, but the similar one in a similar facility occurred in 2011 that I was referring to, very, very similar one. And it is really scary how similar that was. That's why I mentioned earlier 2010 or 11, but this particular case occurred in 2000. However, the timeline is still quite significant. Since 1950, the originally designed or originally fitted T-piece that's been modified. There were several changes starting from 1986, and now here we are in 2000. 11 weeks before the accident, 19 startup attempts, but only 7 were successful. So failure of the T-piece connection pipework was probably caused by a combination of the incorrectly fitted T-piece connection, the inadequately supported pipework. This was a top-tier establishment according to the COMA regulations or the Seveso directives, and the safety report didn't reflect to the current situations. And incidents previously occurring as a result of vibration of the transfer line were not reported nor investigated. And there was an ongoing construction within the site of a new facility. Now, that was a really, really connecting underlying cause here. And that facility, the construction phase, was contracted out, and it was further subcontracted out, which resulted in this case, according to the investigation report, in lack of supervision and lack of following procedures. Now, and this is the aspect that is related to normalization of deviance. Now that we have identified what were the underlying causes and circumstances around this accident, I would like to show you some useful metrics so that how you can be prepared, because in hindsight, everybody knows that, yeah, okay, from the investigation report we have these findings, but how can I apply these findings and learning points in my operation so that I can prevent such accidents to occur, rather than just going after it and identify and make recommendations after the accident already occurred. So there is a metric in the ISC guidance document that is related to compliance with safety critical procedures by observation. In this particular case, I collected some of the features from the circumstances, what could be associated with this particular lead matrix. So for instance, critical procedures such as startup procedures should be correctly followed. In this case, the incident that occurred in 1999, because that was an incident during a prolonged startup, resulted in an ignition of a torch oil vapor cloud. And contrary to planned operating instructions, the torch oil was admitted to the regenerator when the unit was at too low a temperature. The plant actually was a really good plant in terms of that it had a really solid procedure, many solid procedures in place. Yet the operating procedures were for some reason ignored by staff. Open management of change on safety critical elements. There were, as we could see, certain modifications of the plant, and especially removing the valve on the pipework at the base of the column, which supported the pipework and the T-piece connection originally. Another metric that could be useful would be number of non-conformances found in process safety audits. And I would like to highlight that you can find this in many other case studies. And so, for instance, I might think about Texas City Refinery explosion, where previous process safety audits highlighted some of the problems which were not addressed by the management. Now, in this case, the safety report I would like to refer to here failed to reflect the reality of the condition of this unit, and the revision in 1997 or 98 concluded that hardware and software controls in place on the FCCU are adequate to prevent the occurrence of a major accident. Now, it seems that it was not the case, but it was sold by the company. And remember that this was a really good company that followed the regulation, implemented operating procedures, and so on. And metrics related to culture. Remember, I mentioned earlier changes in the safety culture. So there were incidents, and these incidents were not investigated, reported, and obviously that means that the learnings were not communicated or implemented within the operation. And the company reviewed why the unit had struggles to find out more about why it didn't operate properly, but these findings were never implemented or communicated properly. So this is the first case study that was related to a process safety incident. And I know that this is really close to most of you, because this is what you work within, and this is the environment that you are familiar with in this operation. Now, as I mentioned earlier, I will have a second case that has nothing to do with process safety, and if you are ready, then I would like to start with that particular case. I still encourage you to add your comments and questions to the question box, because that is always useful to come back and get feedback. And especially if you disagree with something, or if you would like to add something, that I'm really open to hear from you. Now, I don't know if you are familiar with the Herald of Free Enterprise case. It was a ferry, and this particular accident occurred in 1987. What happened here? The ferry was leaving the harbor for Dover when water entered the hold and car decks via an open bow door. The Herald of Free Enterprise, in this case, unfortunately took the lives of 193 people when it sank. And the Herald of Free Enterprise passed the port at 6:24 p.m. and it capsized approximately 4 minutes later. Even though the ferry didn't sink entirely, as it was in shallow water above a sandbank, there was not enough time for passengers and the crew to escape. Let's see why I chose this case study to demonstrate creeping changes. And you will see also some of the aspects underlined. The bow door, which was left open, was used for loading vehicles. And the ferry didn't have bulkheads within the car decks for faster load. And it was a normal practice on these type of Ro-Ro ferries. What else? When the water entered the ship, it moved to one side of the deck, so the ship became unstable. Most ships had divided hulls, but Ro-Ro ferries tended not to because of the difficulties of loading their cargo and the desire to maximize loads. So the Parliament Act requiring divided hull, but lobbying resulted in it being repealed. So this is a change that is indirectly, but it is a creeping change, so that the lobbyists, they managed to escape from that Parliament Act that required to have divided hull, which had an overall impact of how the ship behaved in this particular case. What were the other circumstances? The assistant bosun, whose job was to close the bow doors as the ship left harbor, had fallen asleep in his bunk. He was really overworked and really exhausted, and missed the loudspeaker warnings that they were about to depart, and therefore he was missing from his station to close the doors. The bosun was on the main deck, but he didn't consider it his duty to close the doors. The other aspect is that is related to the design was that the doors were not visible from the bridge. Standing orders required captain to assume vessel in all respects ready for sea if no report to contrary. Now you can see here that something is odd and something is off, because he couldn't see whether the doors were open or not. Now let's come to the details more. The first ferries before that had these so-called visor doors. So the captain could see from the bridge the status of the doors, whether they were closed or open. But then the door design was changed to a clem type. The clem type were the ones that were not visible anymore. So here is something that you can associate with creeping changes. Sailing with open loading doors, an identified issue. So everybody basically knew about that. Sometimes these ships sailed with open loading doors. So therefore, captains asked for indicator lights for these Ro-Ro ferries to be installed. So they asked the management, but their requests had been ignored. A recent change in ownership, and here is what I mentioned around the change in ownership. So the holding company had only owned the company for a few months before the accident occurred. And there was other aspect as well, so that carrying of excessive numbers of passengers, 10 to 20% more than the loading limit was. So more passengers carried than life-saving equipment supplied. And what else? 3 crews and 5 sets of officers were employed, but there was no consistency in the duties. So they were always new people coming around, and they were not aware of the procedures, and there was no consistency. After that, we have seen these circumstances. I quickly want to go through, because time is limited, what are the leading, even though process safety lead metrics, but what are those that could be associated with this case and can be learned from this particular case. So if you think a little bit broadly, okay, just out of the box, what are the aspects? I have identified by myself, but you can identify more because the report is available for everyone for free on the Herald of Free Enterprise. And if you are interested in going into the details, then you just go and I'm pretty sure that you will find more aspects as well. Conformance with process safety related role competency requirements. Personnel were overworked. They couldn't implement work activities because they didn't have procedures in place. And of course, there was a change always in the crew, so there was no consistency, as I mentioned earlier. And so therefore, I would question basically the competency, because if you are not familiar with the ship that you have duties on, obviously it can have a certain impact on how you operate or how you work on that particular place. What else? Engineering and design. So a high number of failures upon demand indicates in the engineering design issue and improvement in the effectiveness of the inspection and maintenance of the barrier, or determine if the demand frequency matches the design of the protection loop. The lack of divided hulls, for example, is a lack of barrier in place in this case. Open management of change on safety critical elements. The change in the design of the visor doors should have gone through a management of change process. And failure of primary containment on inspection and barriers failing on test. The same metric could be applied considering the several occasions ships had left the harbor with open doors, and that captains asked for indicator lights to be installed. So these are the lead process safety metrics that I could think of and associate with the Herald of Free Enterprise case. Now we have reached the point where I guide you through the what can I do session. These are the recommendations focused on typical roles which are applied for management, for process safety, engineers or supervisors and operators. And you can find, I also published a safety law that is a PDF document, can be downloaded for free from our website on creeping changes. And there you can see the first case study and in details, and also you can find the podcast about that safety law uploaded to our website as well. Now, in general, because when I prepare these what can you do sessions, I gather more accidents, so that I don't base these recommendations only on 1 or 2 case studies, but many, many more. Normally, I take the examples of like 10 to 20 case studies that I research, and then find similar findings and similar recommendations that can be applied in the industry. About management of change, if you are a manager, then changes in management or ownership can have large consequential hazards. So therefore, it is really crucial to follow up and have these procedures in place. Incidents often occur after some change in the system or the original design. So make sure that changes as a result of adoption of new or even altered processes, loss of skills, and new knowledge brought into the operation go through management of change procedure. And as I mentioned earlier, everything is changes. The climate, operation, people, everything changes. So that make sure that you apply strategies to adapt to changing environment and changing in the overall safety management system. When we talk about design, then try to ensure audits address changing behavior and check that the process is carried out as it originally was designed. Could be changes and differences between the designed and the built system, how it is supposed to be and how is it in reality. if a particular incident scenario that you identify is not considered in the design phase, but still that incident scenario is possible, then it needs to be incorporated into the leading metrics program, should you have one in place. How to detect? So what are the signals of the change? Really, really difficult to detect. So try to implement a system and structured process for identifying those changes and detecting how the process should operate and what is the current status. If you know where you are at the moment and how you should operate, then you can see the deviance between the two, if there is. If there is none, then everything goes around and goes with how you should operate. Try and implement leading metrics in the risk management program, responsibilities assigned for checking those metrics. So not just gathering metrics just to have them, and it's not about the number, it's about the quality of those metrics. And it is about whether you know why you are collecting information on certain metrics. And action plan should be followed to ensure that these leading metrics actually exist. So they are not just exist on paper, but really, really exist and tried and tested and reviewed and updated when it is necessary. What to do about incidents? Try to ensure that change is detected. Even small ones are documented. Near misses, for instance, they can be a signal for a big catastrophe. In case of an incident, check if you had already had leading metrics in place, or whether they were missing, or whether they were not performing well, and why they failed, if that was the case. And try to have effective action on that, and try to analyze why there was no effective action taken so that they could fail. I already mentioned the near-miss events that highly encourage you to identify and investigate them, as they can be precursors to a major incident. Remember, in Nimrod case, over 23 years, fourfold number of leaks occurred. And if you think about other major incidents or tinier incidents, then you can see the same pattern over the years, that they can be overlooked over time. What about costs? Make sure that costs do not impact safety and they do not threaten plant integrity. And make sure it is also related to costs indirectly, but it is, that process knowledge is maintained and transferred. It's a sensitive topic, I understand. Costs are always sensitive topics, especially for engineers. What can you do as a process safety engineer or supervisor? Make sure that you record trending of leading metrics and ensure that process functions as it is intended based on the original design. And every change in the document, particularly safety critical ones and near misses, that should be recorded, should be documented and incorporated in the operating procedures. Try to have up-to-date plant layout drawings, remember back to the case study, and maps to follow up changes and keep record of the original design layout. And this is crucial because I'm pretty sure that you've heard of that, that you have all the documentations and archive in the basement, but it is important to keep them and to remember where you can find that archive, because sometimes you have to check how much you altered from the original design. Even if you use a certain different quality of materials, of valves, for example, which altered from the original design. So those can have impacts. When you start up a process unit, it can result in significant changes in the pipework and vessels. I talked about it in terms of vibration and fluctuation in conditions that increase cyclic stresses on mechanical systems. Try to pay attention to these signs of normalization of deviance, where operators might just skip one or two steps from the procedure, or they just ignore the procedure, or they just bypass it. and report and investigate all cases and try to communicate the findings of those results. And finally, we have reached a point where I can show you what can you do as an operator. So you can make sure that you follow these operating procedures and the maintenance procedures and the emergency procedures, and never deviate from them unless the procedure is wrong. I get this from time to time that yes, operating procedures may not be perfect. Okay, just be aware. Try to follow them, and if you see that it is not that it has some failures in it, then try and tell it to the supervisor and discuss this with them. Report any damage or irregular event immediately. And as I mentioned earlier, I was too fast to mention it, okay? If the procedure cannot be followed, then report it and find a solution. So I'm pretty sure that you can have more of these, and obviously you can, because if you research more on this, the creeping changes, then you will find more and more information. So for instance, if you go to the website of the Energy Institute, they have published a very, very good guidance document on hazard identification of creeping changes. And I think it was published back in 2010, but I would highly recommend that publication to you. And at the same time, the IChemE Safety Center is also working on with a technical working group on a very, very similar aspect, and we are going to publish a guidance document on a topic that is related to creeping changes. And in the future, we are publishing or releasing an interactive case study, most probably next year, about creeping changes and system-based thinking. So what are my conclusions? These are just my conclusions. You can take others. You can skip some of those. But what I try to convey to you, and I hope that I managed at least like, I don't know, 70–80%, but the aspects that there are subtle but gradual changes to the system that obviously can contribute to major accidents. And having lead metrics in place are really helpful, because then you can monitor the process and the changes within. If you have appropriate knowledge and understanding, then you know what are the lead metrics that you want to apply and why those especially, because every industry is different and every operation is different. Therefore, you can have absolutely different lead metrics in place. The leadership, as I mentioned, is crucial. Make relevant stakeholders aware of their own responsibility. Someone has to be responsible all the time that what is happening in the plant and why those changes occur and how those changes can be assessed, and whether they are related to the risk assessment process, and where to find them. With the necessary care and vigorous monitoring of the system, these changes can be captured in time. And that's why I try to highlight some of these lead metrics. So maybe that help you. And especially that this is the one that I refer to, the Energy Institute publication. Personally, that is my personal opinion, that you can take it as an example. And now I run a little bit over time, but I'm happy to take questions. And I think that we have like 5 to 8 minutes to take questions for the webinar.
Yes, we do, Susanna.
Sorry, I ran over time.
No worries.
Just 1 second.
Thank you very much. It was a very engaging talk.
Yeah, if you send the questions either to courses or Safety Center or Christiana, then I will be able to respond more details. Okay.
Brilliant. Thank you very much, Susanna. That was a really great talk. And we have some really good comments and questions here. I think some of the questions you might have answered as you went through the presentations, and some excellent comments around change, around savings, and the impact of COVID as well on reduced work numbers, and how that can impact increased maintenance logs, backlogs as well. The one question here that I think was quite interesting was about the robustness of root cause analysis, especially with regards to the first case study on the FCCU unit. And the question is from Ian Welburn, and his point is the TPs remained an unrecognized component after so many restarts. And I wondered if you could speak or comment on that.
Yes, thank you so much. This is a really great question because, as I mentioned, but I was really brief about that it was covered by lagging. So nobody actually could see the TPs and its condition over time. I don't remember exactly the details how they finally discovered. I think it was only after the incident, but unfortunately that was an aspect that contributed to the accident, that it was hidden by lagging. I hope that that answered to the question.
Thank you, Susanna. There's another one from Richard Mundy, and his question is that in some jurisdictions, a thorough inspection and review of a unit is mandated when the original design of the unit elapses. And presumably this may have caught some of the incidents at the FCCU unit. And he wonders if this is something other areas should consider.
Considered by the regulator or considered by the
regulator? By the regulator.
Yes. Yeah. I'm pretty sure that the regulator is really aware now that they should check also this aspect of on creeping changes. But it's really, really interesting, and thank you for the question. And especially because the same, as I mentioned earlier, that the same very, very similar incident occurred in 2011. And I think that they already established some learning points around these subtle changes, even if they didn't call it as creeping changes.
Thank you, Susanna. There's another question here from Ian Welburn around the detectability of the integrity of barriers. So Huracans is something that needs reviewing because the MOC is only as good as the visibility of where the process exceeds operating barriers. And I wondered if you had a comment on that.
I'm afraid not at the moment. It's a very complex, very good, very valuable comment. I highly appreciate it, but think it's really like a very, very short time to get into the details.
Okay. We have another question from Nigel Kearns, and his question is about the contribution of lobbying to safety events. So he says some sites have pushed back on the implementation of some practices. Examples are the recognized and generally accepted good engineering practices, RAGAGEP, and on the basis that they follow local legal requirements. And if the legal requirements are at the mercy of lobbyists, their primary focus is not safety. I wonder if you had a comment on that, the impact of lobbying on process safety events.
Yeah, I see the comment, and it also says that if the primary focus is not safety, legal requirements will always leave your barriers being at least partially degraded. Yes, unfortunately that's the case, and it's quite a sensitive topic. But I think that as engineers, you can make your point. And especially for lobbyists, that all right, that you can try to lobby for that change to occur, but then you have to see the whole picture, and that's why I highly encourage engineers now to come and recognize the importance of system-based thinking. That means that if you can draw the attention and pay them more attention to the factors at the system level, rather than just seeing that particular piece of equipment that they are lobbying around, or that particular one ship that they are lobbying, or local issues, then they should be able to see also the full picture. I think that's the message that I would like to give.
Thank you, Susanna. I'm afraid we're out of time, so we'll leave it there for this webinar. but it's been very engaging. We have lots of good comments and lots of good questions. And the slides and the recording will be sent, and the link to the recording will be sent after the presentation. Can I please ask that you respond to the short survey that will be sent across as well? That will give us an idea of any additional topics you reckon is worth considering, especially regards to industrial systems. So thank you again, Susanna, for that excellent webinar. And we hope to welcome you back for more webinars in the future.
Thank you. And I would like to say that I have saved the questions. And for those who asked a question, I will come back by email with my answer so that you are not left without any response.
Thank you, Susanna. It's very kind.
Thank you.